Hi guys, welcome back to my channel. And now I will also be talking about, I'll be continuing to discuss about IMONST problems. So to help us prepare better for the contest, the organizer has actually uploaded a new sample paper up to the website. I'll link the website link down below. And here are the problems, but they are now more divided into, like, how do I say, primary, junior, and senior, to better apply to the students going for the competition. But now I'll only be discussing the senior part because I'm a little bit lazy. Okay, so in this part in this video we'll be discussing problems 1, 2, and 3. So let's look at problem 1. So given that 4 to the power of n equals to 2 to the power of 2 to the power of 3 to the power of 2 to the power of 2, find n. So normally when we approach these kinds of problems, these are exponentials, as we say. No. So these things are called exponentials because I saw the live stream of Encik Zafri with Encik Shafiq, actually. Exponentials. And normally the way we do it, if there is an absence, or if there is no brackets, or should I say, if I do not do, I put here first. If there's nothing like this, normally we'll do top down. Top down meaning that, oh, for this one we would do this one first. So 2 to the power of 2 is 4, and then we have 2 to the power of 3 to the power of 4, and then we'll do this as the next one. Then we'll just do this as 2 to the power of 2 to the power of 81. So this is our method of doing. And now we want to equate this 4 exponential and then with this 2 exponential. So what we'll do here first, because we know 4 is 2 to the power of 2, so we can turn it into 2 to the power of 2 itself times 4 to the power of n times. Okay, so because these are multiplicative, so when we bring it out, we will have 2 to the power of bracket 2 times 4 to the power of n. So now we have our same base, which is 2. So this one, you can remove it, and then we'll just look at its indices. So now we'll have 2 times 4 to the power of n equals to 2 to the power of 81. And so dividing both sides by 2, so this one 81 minus 1, 4 to the power of n equals to 2 to the power of 80. And then using this fact again, we can see that 2 to the power of 2 times 40 is actually equals to 4 to the power of n. So these two are the same again. So our n is just 40. So let me jot it down. And take a look at problem 2 first as I erase some things. Okay, now on to problem 2. So this problem says that determine the greatest integer such that no digit appears more than once and no two neighboring digits have difference of 1. So since we want the greatest integer and then no digit appears more than once, so normally what we first think of is that we will need to use all the digits from 0 to 9. So let me list them all out. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. And no two neighboring digits have different ones. So if you want the maximum, normally at the leftmost, we'll put 9. And then the second leftmost, normally we'll put 8, but now we cannot have a difference of 1. So it must have a difference of at least 2, because we can't have difference 0, and that because that means they are the same number. So if we can't have 8, then we'll just put 7 over here. And then to the right of 7, we could have put in 8 or 6. No. So we'll just put 5 over here. And then now you see that this 9, 7, 5, they are gone. But then you can see this 5 and 8 have difference 3. So actually it is feasible to put it inside over here. And then next we have 6 over here. And then for the rest we have 4, 3, 2, 1, 0. So for maximum we will have 4 over here. And then for the maximum value we will have put in 2 over here. So now what we are left with is 0, 1, and 3. But now 1 and 3, 2 is between 1 and 3. So obviously we can't use both of them. So we will have 0 over here. And then 0 and 3 differ by 3, 0 and 1 differ by 1. So we cannot put 1 beside 0. So this is 3, and then the last digit would be 1. So check if you have the same answer as mine, but I'm not sure if I did correct. So if I did anything wrong, just correct me in the comments below. 2031. So this is the answer. And I'll erase some things and then you can look at problem 3 first. So problem 3 states that given a 6-digit number n, how many 7-digit numbers are there such that when we remove one of its digits, the result is n? So let's simply make up a 6-digit number, maybe say 142857, okay? So I'm just making this up, randomly generating. So we can imagine that if you want to add in an extra digit, we have 1, 2, 3, 4, 5, 6, 7 slots to add in this number. Me writing this means that I can put any digit over here, this place, so 7 in total. And we look one by one. For the leftmost one, it is obvious that we cannot put 0 because it is, how do I say, it doesn't count as a 7-digit number if we do so. So we could have put in 1, 2, 3 all the way up to 9. So there are 9 choices over here. And then in this place, this is where it gets interesting because let's say for 1, just now if we have put in 1 over here, so this number will become 1142,857, right? So if I put a 1 in this place, this one would have become 1142,857. So these two are the same numbers. So which is, how do I say, this is not acceptable. So to the left, if we have placed 1, we could not reduplicate the digits. So from here, actually we can put 0 right here now, but now we cannot put 1 because it's the same as the last digit. So 0, 2 all the way to 9. So here the same, we will also have 9 digits. And then in this place, it's now we have put in 4 to the left. If we put 4 to the right, it will have also yield the same digits. It will yield the same 7-digit number. So ditto for this one. So this one will also only have 9, and then this one will also have 9, then 9, 9, and 9. I do not think I need to explain the analogy for all of these because I have shown you examples of it here. So in total, all we need to do is we just add up all the numbers over here. So very nice, we have 7 9s over here. So 7 times 9 is just 63, which is our answer for problem 3. But to be honest, this is a re-upload of the previous video because I have taken it down because when I was watching Ms. Anjik Zafri's live stream with Anjik Shafiq, I observed that I forgot this point. So yeah, this is a tiny confession to make. So what you're seeing is not the original. So I do appreciate your forgiveness. Okay, so that's all for today. For tomorrow, when the next video comes out, we will be discussing problems for 5 and 6. So stay tuned and have a nice day.